Welcome to our lesson today. My name is Purity Anzelimo. Our topic for today is differentiation. Differentiation. That is our topic. And before I introduce what we are going to cover during this lesson, I would just like to do a review of what we covered in the previous lesson, whereby we were looking at how to identify the stationary points. Identify the stationary points. And just to remind you, when we talk of a stationary point, is a point where the gradient is equal to 0. And therefore, when you are told to identify the stationary point and you have been given the equation of a curve, you've been given the equation of a curve. For example, y is equal to x squared, and you are told to identify the stationary point. You need to come and know at stationary point the gradient is 0, and therefore you need to get the gradient for this, which is dy all over dx, which will be 2 times 1, that is coefficient of x, that is 2x squared minus 1. So we have 2x. So that is the gradient function, and therefore we come and equate 2x to 0 because the gradient at stationary point, at this stationary point, the dy all over the dx is 0. So we find that our x therefore will be 0 over 2. That is by dividing 2 on both sides. We have 2x by 2 by 2. So we get that x is equal to 0. So when you now want to get the point, because we said a point will be shown by both the x and the y coordinate. So we have when x is 0, therefore when x is 0, y should be equal to y is equal to x squared. And therefore this will be y is equal to 0 squared, that is 0. 0 squared is equal to 0. And therefore the stationary point for this, the stationary point is 0, 0. We have x 0 and y 0. That is the stationary point. And again, we see now when we want to get the nature of the stationary point, when you want to get the nature of the stationary point, you simply need to come and have the values of x and then the gradient dy dx at x. So you can have at the center you have the value for x when the gradient is 0. Then you choose a point towards the right and the left. So a point towards the right, I can choose 1, I can choose -1. And therefore dy dx at x, the equation for gradient is 2x. So when x is -1, this will be -2. And we have when x is 1, this will be 2. Meaning that our gradient here is negative and here is positive. And therefore we have it as negative, we have 0, and we have positive. This is -0, positive, and therefore our stationary point is a minimum. The stationary point is a minimum. So that's how we identify the stationary point and also the nature of the stationary point. So in this lesson, I would like us to look at curve sketching. Curve sketching. So in this we are sketching curves. Now you know very well that when we talk of a sketch, when we talk of this sketch, it must not be the whereby you plot all the points. In sketching, you choose some few points which are very key. For example, in our sketching, we are sketching the curves, and therefore you choose some very important points in a curve, and then you are able to sketch. In sketching, you must not sketch in a graph paper. You can sketch in a plain paper. because you only show the very major points. And therefore, we see that a sketch of a curve, shows the shape. It shows the general shape. It shows the general shape, and maybe other important features, of a curve. So a sketch of a curve shows the general shape and other important features of a curve. Now, in sketching the curve, we are going to consider the intercepts, that is both the x and the y intercepts. We also need to consider the turning point. So we will consider, that is, in sketching the curves, we'll consider one, the intercepts. Where does the curve cut the y-axis and where does it cut the x-axis? Then number two, we'll also consider the turning point. It can be one or two, that is, depending with the curve equation. Then number three, what also we require also to know the nature of the turning point, or the nature of the stationary point. Is it a maximum? Is it a minimum? Or is it a point of inflection? So a sketch of a curve shows the general shape and other important features of a curve. And we consider, when sketching the intercepts, that is both the x and the y intercept, the turning point or points. We also consider the nature of the stationary point. Now, I'd like us to do an example whereby we are going to sketch a curve. So in this, we are told to sketch the following curve. Sketch the following curve, and the equation for the curve is y is equal to 3x squared. I want us to sketch that curve. Now that we have covered all this, whereby we were looking at how we can get the stationary point, the nature of the stationary point, then this is very easy to sketch the curve. So we are going to follow these three: the intercept, the turning points, and the nature of the turning point. Then we sketch. So we are told to sketch the curve y is equal to 3x squared. So I want us to start with the intercepts. We need to get the intercepts. That is the x-intercept, and also the y-intercept. So we can start with the x-intercept. The x-intercept is the point where the curve cuts the x-axis. So if we have the axis this way, where it will cut the x-axis, this is what we refer to as the x-intercept. And when we want to get the x-intercept, the value of y is 0, because at any point here on the x-axis, the value of y is 0. So our y is equal to 0. So we get the x-intercept, whereby in that case, the value of y is equal to 0. So we simply come and say our curve y is equal to 3x squared. Our y is 0 is equal to 3x squared. We can divide by 3 by 3. So we get that x squared is equal to 0. And therefore our x simply will also be equal to 0. So therefore we have the x-intercept, whereby our x is equal to 0, and again our y at that point is equal to 0. Again now we come and get the y-intercept. On the y-intercept, again, if we have our Cartesian plane this way, a line that will cut any point, that is the y-intercept at this point, our y-intercept is that this point or this or any other on the y-axis, and therefore it means that at any point on the y-axis the value of x is 0, because our point here is 0, so any point will be 0. So on the y-intercept, therefore our x is equal to 0. So when we get, now we come and get the value of y, so we have the equation y is equal to 3x squared. Our y is equal to, our x is 0, 0 squared times 3, we get 0. And therefore, for the y-intercept, we have 0.0 for x and 0.4 for y, we have 0. So we have 0, 0, 0, 0. That is the origin. So we have x-intercept and also the y-intercept. Then we move on and get the turning point. The turning point. In our case, the equation, so we are now in the turning point. Then we are going to sketch the curve, the turning point. We know that at the turning point or at the stationary point, the gradient is 0. And therefore, if we have our equation 3x squared, therefore, the gradient dy all over dx should be equal to 0, which is dy all over dx is equal to, this is for the stationary or the turning point. This is for a stationary point. So we have, when we differentiate, we get 2 times 3, that is 6, x raised to power 2 minus 1, which is 6x. So our gradient is 6x. So 6x is equal to 0 at stationary point. So when we divide this by 6, we end up getting that our x is 0 over 6, that is 0. And therefore, we want to get the turning point. This turning point, therefore, will be y is equal to 3x squared. Therefore, we have our x as 0, therefore y will be 0 squared times 3, that is 0. So the turning point is, or that stationary point, therefore, will be, the stationary point is, we write the stationary point. So the stationary point, or our turning point is, therefore, for x we have 0, y 0. Then we move on, finally, the nature of the stationary point. So we just come and get the values here of x, then the gradient at x, so that we can see the nature, gradient at x. So we have, when the gradient is 0, our x is 0, when the gradient is 0. So we get a point towards the left and towards the right. So we get the gradient at x. And we know that the equation for the gradient dy all over dx is equal to 6x. 6x. So we have negative 1 times 6, negative 6. 1 times 6, we have 6. So we have negative, and then we have 0, then positive. So we have our negative, we have 0, and we have positive. This is negative gradient, this is 0 gradient, this is positive gradient. And therefore, our curve should, the turning point or the stationary point should be a minimum. Now we can come and sketch that curve. We sketch, now we have the intercepts, we already have them here. This one and this one, we already have the turning point, which is 0, 0. We also have the nature of the stationary point, which is a minimum. So we just come and sketch now. We've said you can even sketch on a plain paper, because a sketch will only show, it shows the general shape of the curve and any other important feature on that curve. So we can come and simply sketch it, so that we know that our intercept, we have 0, 0, 0, 0, so it is through the origin. Again, the stationary point is 0, 0, meaning that, and we have it as positive. So the only point that we have is this point, that is 0, 0. Because for the y-intercept, the x-intercept, we have it as 0, 0, and 0, 0 is the origin. It's simply the origin. This is again the origin. Again, the stationary point is at the origin. The stationary point is here at the origin, meaning that because it is a minimum, Therefore, it simply means that that's our curve. That's the sketch that we have. So that's the sketch for the curve. It is a minimum, this the minimum, and we can see that it is at 0, 0, and we have any other point at that point. So the x-intercept, 0 origin, again the origin, so we have it that way. That is the sketch for the curve. Then we can do another example, example 2. Again, we are sketching. I want us to sketch another curve. So example again, example 2. Sketch the following curves. Sketch the following curves. Sketch the following curves. And I want us to sketch one more. The equation is y is equal to x cubed. Y is equal to x cubed minus 3x squared, 3x squared. And I want us to follow the same procedure. With the first one, it is very direct because everything is 0, 0, 0, 0, and we know that it's a minimum. So in this one, I want us to move step by step again. We start with the intercept, the turning point, that is the stationary point, and also the nature of the stationary point. So we start with the intercepts. We start with the intercept, then we move on to the turning point, then the nature of the stationary point. So we start with the intercept, that is, we can start with the x-intercept. The x-intercept, we have seen at this point y is equal to 0. So we simply come and say our equation y is equal to x cubed minus 3x squared. So we equate this equation to 0 because y is 0. So we'll have x cubed minus 3x squared is equal to y, and our y is 0. Then we can factor out the common factor, that is x squared. We have x minus 3 is equal to 0. We want to get the x-intercept and the y-intercept. So here we'll have, therefore, x squared is equal to 0, and therefore x is equal to the square root of 0, that is 0. Again, we have x minus 3 is 0, therefore x is 0 plus 3, that is 3. So we have two values, x 0, x equal to 3. So we need to get the intercept, that is for the value of y when x is 0 and the value of y when x is 3. So we have our equation y is equal to x cubed minus 3x squared. So when it is 0, we are going to have this as 0 cubed minus 3 times 0 squared. We get 0. And therefore in this we get the value of x 0 for y 0. Then again here, y is equal to x cubed minus 3x squared. So our y will be, our x is 3 cubed minus 3 squared. This will be 27 minus, this is 9, again 27. So we have 0. So our coordinates here, we have x 3, y 0. So those are the intercepts, 0, 0, 3, 0. That is the x-intercept. Then we move on to the y-intercept. The y-intercept. And the y-intercept simply means it is when x is equal to 0. So our equation y is equal to x cubed minus 3x squared will therefore be equal to 0 cubed. Then we have minus 3 times 0 squared. We end up getting 0. And therefore for the y-intercept we have x 0 and y 0. That is the origin. So here we have the origin, and again for this case we also have the origin. Then after getting the intercepts, we get now the turning point, which is again very easy, the stationary point. We get the stationary point. Stationary point. So we simply come and say at stationary point, then gradient dy all over dx is equal to 0. So we have our equation y is equal to x cubed minus 3x squared. So our dy all over dx will be 3 times 1 here, which is the coefficient of x. We have 3x, 3 minus 1, then minus 2 times 3, that is 6, x 2 minus 1. So we are going to have this as 3x squared minus 6x. So, and we know that at that stationary point the gradient is 0, so we equate that to 0. So we have 3x squared minus 6x is equal to 0. The common factor here, we have 3x. So we are going to have x minus 6, not minus 6, because the x 6x minus divided by 3x, we have 2 is equal to 0. So we get the values of x. The first one we have 3x is equal to 0, divided by 3 by 3. So we have x is 0. And when x is 0, we can get the values of y. Then the other x, we have x minus 2 is equal to 0. And therefore x will be 0. We take 2 to the other side, we'll have plus 2. So we have our x as 2. So we want to get the corresponding values of y when x is 0 and when x is 2. So our y is equal to, the equation is x cubed minus 3x squared. So when x is 0, all this will be 0, and therefore we'll have the point as 0, 0, which is the origin. Point 0, 0 is the origin. Then when x is 2, we have the equation y is equal to x cubed minus 3x squared. So when it is 2 here, we have 2 raised to power 3 is 8, minus 2 raised to power 2 is 4. 4 times 3 is 12. So we have 8 minus 12, which is negative 4. We have negative 4, and therefore the points are x2, y negative 4. Then now, after getting the stationary point, we have the stationary point and another stationary point. Finally, we look at the nature of the stationary point. Nature of the stationary point, so that we can now be able to sketch the curve. So nature of the stationary points, there are 2. In our case, we have 0, 0, and we have 2, negative 4. So we come and now get the nature of the stationary points. Nature of the stationary point. The first one we have point 0, 0. So we just come and get the values of x, and then the gradient y dx at x. So we get the points here. The middle one is when the gradient is 0. So x is 0, the gradient is 0 at the turning point. Then we get a point towards the right, like 1, and towards the left. Then we simply come and say, we know that the equation dy all over dx is equal to 3x squared minus 6x. So we have, therefore, when x is negative 1, we have negative 1 squared, that is 1. 1 times 3 is 3. Minus negative 1 times 6, we have negative 6. Negative 1 times 6 is negative 6. So we have negative 6. This is 3 plus 6, which is 9. Then again, when x is 1, here we'll have simply 1 squared, that is 1 times 3. Then minus 1 times the 6, which is 6. So we have 3 minus 6, which is negative 3. And therefore, we have positive here, positive gradient 0, and then we have negative. And therefore, we have it this way. We have positive, we have 0, and we have negative. Positive, 0, negative. And therefore, this point is a maximum point. Then we move on to the other point, that is 2, negative 4. Again, we come and get the values of x, and then the gradient y dx at the point x. So at the mean row we have the point 2 where the gradient is 0. So we get the other gradient here, and we know that dy all over dx is equal to 3x squared minus 6x. So we get a point towards the right, we have 3, towards the left we have 1. So we come and get the gradient when x is 1. So we are going to have here 3 minus 1 times 6 is 6. So we have negative 3. And when x is 3, again, we are going to have 3 squared, that is 9. 9 times 3, we have 27. Then minus 3 times 6, that is 18. We get 9. So we have 9. So the gradient here is negative and here is positive, meaning that we have negative, we have 0 gradient, and we have positive. This is negative, 0, and we have positive, meaning that our point here is a minimum point. This is a minimum point. And therefore now we can move ahead and now plot, that is sketch the curve. We sketch the curve because we have the intercept. We have the intercept, that is 0, 0, and we also have the other point 3, 0. These were the intercepts. So we need to write those intercepts. Then we have the intercept. The first one we hand 0, 0. Then we hand the other one 3, 0. Then we hand the other one again, the origin 0, 0. Then we have the stationary points. The first one we have point 0, this point 0, 0, which is a maximum point, 0, 0, which is a turning point. This is a turning point. And then again we have another turning point 2, negative 4. This is another turning point. So we need to come now and sketch the curve. We just include whatever we have, 3, 0, we have negative 2, negative 4. So come and have the sketch, whereby we are going to have therefore the sketch for the curve and see the general shape of that curve. So we have on the side of negatives, so it's a sketch. So we can have on the x-axis, we have the highest 3, so we have 0, 1, 2, 3. Then we have negative 1, negative 2, negative 3. Then on the y-axis we have 0, we have negative 1, negative 2, negative 3, negative 4, negative 5. We have 1, 2, 3. So we have point 0, 0, which is this, which is a turning point, and it is a maximum. This one is a maximum. Then the other one is a minimum. And we have point 3, 0. So we know that we have this point 3, 0. So we have the turning point, we have 0, 0, and we have 2, negative 4. We have 2, negative 4. So this other point. So our 0, 0 is a maximum, and then our 2, negative 4 is a minimum. So we have it this way. This is a maximum. Then we move on to the minimum point. Maximum, then minimum, then we have point 3, 0, which has helped us to plot the curve. So we have that way. And that is the sketch for the curve, whereby we have point 0, 0 is the maximum, point 2, negative 4 is the minimum, and this point also we've used it to help us get the nature and the curve, how the curve looks like. So that's the nature of the curve, maximum and minimum for the curve that we had been given, whereby y is equal to x cubed minus 3x squared. So to determine, to be able to sketch a curve, you need to get the intercepts, you also need to get the stationary point, and finally determine the nature of the stationary points. And then you can be able now to plot or to sketch the curve. So I'd like you to sketch the following curves. sketch the following. Sketch the following curves. Sketch the following curves. So we have number 1, y is equal to 3 minus x squared. Number 2, we have y is equal to x squared minus 3x raised to power 3. Then finally, number 3, we have y is equal to x into bracket x minus 2 squared minus 2 squared. So ensure that you sketch the following curves. That is, 1, get the intercepts, x and y intercepts, then the stationary point or points, the stationary point. They can be more than one. Finally, you get the nature of the stationary point, nature of the stationary point, and then finally you come and sketch your curve to show the general features or the general shape of the curve. Thank you for being attentive throughout the lesson.